Morning guys, Marini here with another stats video. Gonna try and keep this one as short as possible. If you don't want to see the answers to the do now yet and you want to work on it by yourself, you can go ahead and pause the video. I'm gonna highlight the answers now. Okay, so this is the actual lesson for today, a two-sample t-test for a difference between two means. Mr. Marini believes he has more average likes on Instagram per week than his wife. Mr. Marini gathers data and determines that in an SRS of 40 weeks, the average likes were 125 with a standard deviation of 37. And in an SRS of 35 weeks involving Mr. Marini's wife, she had an average amount of 115 likes with a standard deviation of 43 likes. Is there significant evidence at the 5% level that Mr. Marini averages more likes per week than his wife? So I see here that it's a means question, and it's asking us if we have evidence for something. So this is going to be a significance test. So step one is we want to test a claim about, or we want to test a claim about the true mean difference in likes per week on Instagram between Mr. Marini and his wife. The null hypothesis and the alternate hypothesis. Again, the null hypothesis is that the likes per week is the same. We're going to use an equal sign. We're not going to write P1 equals P2 because that would be for proportion. mu1 equals mu2. And we'll write down what that stuff means in a second. Now, the question says, is there evidence that Marini averages more likes per week than his wife? So depending on how you set up mu1 and mu2, you might use a different symbol than me. I'm going to write mu1 is myself, Marini, and my wife is going to be mu2. And I'm looking for evidence that I get more likes per week, so I'm going to put a greater than sign there. And now I'm going to go ahead and label. And then mu2. All right, so that's step one. Step two. This is a two-sample t-test. And why is it a t-test and not a z-test? The standard deviations that are in the problem are from the sample of 40 weeks and 35 weeks. It doesn't say that's the population standard deviation. So it's two-sample t-test. So you're going to check our three conditions. First one, random samples. We do have random samples of weeks for both myself and my wife. Second is the 10% condition for independence. We're going to have to assume that there are greater than or equal to 10 times. And now my sample size for myself, which was 40 weeks, all right, so we're assuming that there's at least 400 weeks that I've had Instagram. And, you know, that's about, what, 5, 10, 15, 20, 8 years? Yes, I've had Instagram for at least that long. We're also going to have to assume greater than or equal to 10 times 35 weeks for Marini's wife. And that's good too. So we're not assuming that there's at least 400 pictures that we're looking at for Marini and 350 pictures. It says that they picked 40 random weeks and 35 random weeks to look at. So those are weeks, not individual posts on Instagram. And then we have to check normal. And since this is a means question, we just have to make sure both sample sizes are greater than or equal to 30. So sample size 1, which will be my sample size, is greater than or equal to 30. And sample size 2 is greater than or equal to 30 as well. Because that's 40 and that's 35. So now we're ready for step 3, which is the formula part. T equals so x bar 1 minus x bar 2 is going to be the sample mean for myself minus my wife. Told us in the problem that I had a mean of 125 likes per week. My wife had 115. We can see right there, just from the sample mean, that I have more likes per week than my wife. Now, is that enough evidence to say that I have more likes per week all the time? Well, we got to figure out what our p-value is to make that conclusion. So just putting in the numbers for the rest of the formula. Sample size 1, sample size 2, standard deviation squared, other standard deviation squared. And now again, if you wanted to do this as my wife minus me, then your numbers would be backwards. So calculator. This is a 2-sample t-test. Looking at my calculator right now. Stat tests, 2-sample t-test is number 4. So you put all your data in. Always make sure you're on the stats option. It asks you for all those things. Make sure you use your symbol. Oh my God, I just realized I messed up. Different. I'm not gonna restart the video. The question says, is there significant evidence? Oh, never mind. I'm sorry. I'm thinking of something else. We're fine. Scratch that. Everything is fine. Is there evidence they get more likes per week? Okay. So make sure in your calculator, you're making your symbol a greater than symbol. I was thinking about this question down here that you guys are going to do by yourself. The symbol's going to be different. All right. So number 4 in the calculator, put the numbers in. That gives us a T of 1.07. But more importantly, that gives us a p-value of 0.14, which is kind of high. It's higher than 0.05. So let's make our conclusion then. Step 4. Nope, I was about to do that for a confidence interval. At the, what's the alpha level? 5%? A check, yep. All right, now since our p-value is larger than alpha, we say that it is not significant. So we do not reject the hoe. And therefore, we do not have evidence to say Marini gets more likes per week than his wife. All right, so you guys can work on the next one. Sorry for the little mistake I made or lack thereof. And I'm going to go into the Google Hangout now and let me know what you guys have questions.